Today we learn the basic feasible solution of a transportation problem. A basic feasible solution should satisfy the following conditions. Supply and demand constants are satisfied, non-negative constants are satisfied, allocations are independent, do not form a loop. That we already learned. When the allocation cell is called the independent and when it is called the dependent. Now, allocations are independent, do not form a loop. If the allocations are form a loop, then it is called the dependent. And when they are not forming a loop, that we learned in the last class, and number of allocations should be the m plus n minus 1. Now question is that why we are using the separate method to solve a transportation problem instead of the simplex method. We know the method of the simplex to solve the problem of linear programming problem. We already discussed that transportation problem is a linear programming problem. So why we are not using the simplex method to solve a transportation problem? So in the case of the simplex method, considering the transportation problem, there may be so many constants and so many variables. If we try to solve with the help of the simplex method, it could be the more complex and more iterative. That's why to avoid the simplex method to solve the transportation problem, we are using the different methods to solve the transportation problem. What are the different methods we learned? That first, we use the northwest corner rule to solve the transportation problem. Now, what is the northwest corner rule? Suppose we have a transportation problem with the transportation cost with the available and the demand is there, and available with respect to the sources and demand is with respect to the destinations. Now, since it is a northwest corner is means the upper left corner is the northwest. So we have to start the allocation from here. So we discussed the rules in step by steps. So first step is start with this topmost corner cell where we can allocate is x11. Why we are calling it the x11? This cell is 1, 1. Now how to allocate? We are considering A1 and B1. Which one is minimum? We have to find out the minimum of A1 and B1, and that we have to allocate here. That's why we are considering x11 equal to minimum of A1 and B1. Now question is that A1 may be greater than B1, A1 may be equal to the B1, and A1 may be less than B1. So three cases is arises. Now the step 2. Now we are considering in the step 2 there is the three cases. B1 may be greater than A1. So as soon as A1 is less than B1, so as soon as we are considering A1 is X1, so the available quantity will be 0 in the source 1 and demand at the B1, that the destination 1 is left B1 minus A1. So how much is here left? B1 minus A1, or here is the left 0. So since there is no availability in the source 1, that means in the row 1, we have to move to the row 2. So now we have to allocate the A21. So A21 would be the minimum of A2, B1 minus x11. X11 is basically the A1 in the cell 2-1. Now another case is that if B1 less than A1 in the step 1, what we have to do? That means A1 is greater than B1. So B1 is totally exhausted. That is the demand at the destination 1 is totally exhausted. We left how much available is A1 minus B1. That means A1 minus X11. Now we are allocating, in this case we are moving towards the first row in the second cell. That is the allocation will be X12 and X12 will be minimum of A1 minus X11. That means the B1 comma B2, whichever is the minimum that we have to allocate in the cell 1, 2. Now in the steps 2, case 3, that is if B1 is equal to A1. If this and this is both are the equal, that means after allocating the X11 in the first cell 1, 1, nothing is available is there in the sources 1 and no demand is there. That means the demand is met as per our the requirement. That means here how much left? 0 left. So we have to move to the diagonal. Since there is no available, we cannot move towards the row. Since the demand is 0, we cannot move towards column below. So we have to move in the diagonal. In this case, we have to consider the X22. X22 will be the minimum of A2 and B2. Then after allocating the X22, considering the minimum of A2 and B2, then we have to repeat the steps 1 and 2. Then we have to continue the steps. Now let us consider an example. Let us consider an example to solve by using the northwest corner rule. Solve the following transportation problem by using the northwest corner rule. So these are the cost of shifting commodity from origin O1 to the destination D1. 7. What is the 7? Transportation cost of shifting 1 unit of commodity from the origin 1 to the destination 2. This is 4. 1 origin O1 to the 3, and these are the available at the origin O1 is 5, available 8 at the origin O2, available 7 at the origin 3. Here is the 4 origin or the sources. Destinations means these are the destinations, these 3, and origin, these are the origins. And requirement at the destination, first destination requirement is 7, that means this is the demand. Destination 2 demand is 9, destination 3 is demand is 18. Demand is also is the requirement. But whatever the data is given with the language in the example, we have to consider that. Now at the origin, available is 14. This is the given problem. Now first we have to check the given problem is a balanced transportation problem or a unbalanced transportation problem. Now if we sum up this, 9 and 7, 16, 16 and 18 is 34. That is the demand is 34. And if we check through the column wise, that is the available, 5 and 8 is 13, 7, 20 and 14 is 34. So since summation I equal to summation B is equal to 34, so this is a balanced transportation problem. So easily we can find the initial feasible solution by using the northwest corner rule. Otherwise, we can say, since this is a balanced transportation problem, there exists a initial basic feasible solution. Now, we try to find out the initial basic feasible solution by using the northwest corner rule. First, we follow our step 1. So first, consider the upper left corner. Upper left corner. Here, now see, here is the demand is 7 and available is 5. So minimum is that we allocate in the cell 1 1. Minimum of that, what is the minimum of this? 7 and 5 is the 5. So 5 we are allocating here. Since 5 is exhausted, we cross out and put it here the 0. That means after allocating in the cell 1 1, that means x11 is equal to 5 and no available is left, and 7 minus 5 is equal to 2. So 2 is left at the demand right now in the destination D1. So this is our the first computational table, that is the table 1. Now we move to the next table to check in which direction we have to move. See, since the available is 0 in the first in the source 1, so we have to move in the downwards because that is the demand is till now 2 unit, which we have to meet again. Now in the second table, as the 2 unit demand is there, our available is 6. Since the first available is exhausted, we cross through by a line, or we can block by the defined color this first row. Now here, considering 8 is our the available unit in the origin O2 and demand is 2 at the destination D1. Now minimum of that is 2. So 2 we can allocate here at the cell 2 1. So after allocating this, demand will be 0. So this 2 will be cross out and we left here the 0. And here after cross out the 8 minus 2, since we are allocating here the 2 unit, so 8 minus 2 is equal to 6. Since now our 2 is exhausted, we left only the 0 here. So we cross out this column, or we can block the column because there is no demand, so it is totally blocked. It cannot be used furthermore. So first row and first column is not used furthermore. Now, since there is no unit demand at the B1, so you have to move to the rightward because there is the 6 unit is available. So 6 and destination D2 demand is 9. So minimum of 6 and 9 is the 6. So 6 we can allocate in the cell 2. After allocating the 6 here, how much is left? Is 0 available in the origin 2 and demand is still now after allocating 6 is 3. Since the available is 0 and demand is 3 at the destination 2, so next table we have to move towards the downward in the column 2. Now in the table 4, we already discussed we have to move in the column 2 in the downwards. Now here we have to allocate how much is available is there after allocating the 3 unit and 3 unit, and here available is the 7 unit. So which one is the minimum? 3 is the minimum. In the cell 3 2 we can allocate only the 3 unit. So how much is left available in the origin 3 is 4 unit, and here 3 is exhausted, only left the 0 demand. Meet is fulfilled. So we cross over the destination D2. or we can block by the defined color. Now only since the demand is exhausted and available is there, demand is met and available is 4 units. So we have to move in the next table towards the right in the third row. Now in the third row, that means the origin 3, we move towards the right, that is the cell is 3-3. In the cell 3-3, our demand is 18 units and our available is 4. So minimum of 4 and 18 is the 4. So we can allocate is the 4 here. And after allocating the 4 unit, available is 0. Nothing available is there. And after meet the demand 4 unit, so left demand is the 14 unit. Since the available is 0 and demand is 14 unit, we have to move towards the down in the column D3, that is the destination column 3. Now we are moved to the downwards in the destination column 3. How much is left? 14 unit is our the available and 14 unit is the demand. In the last allocation, both would be the same because this is a balanced transportation problem. If it is not the balance, we have to make it balance by using our the property that we already discussed in the previous class. Now 14 unit we are allocating here. That means available 14 is becomes 0 and 14 demand is becomes 0. So we meet the demand, nowhere the demand is left and our available all are exhausted. Since all the available and the demand is exhausted, demand is met. So this is our the final table. This is also the final table of the northwest corner. Now now we have to check the number of allocations. Here number of allocations is the 6. According to our definition, number of allocations should be the m plus n minus 1. M plus n, m is number of origins, n is the number of destinations. Here 3, m is 4 and n is 3. So m plus n minus 1 be 6. Now our number of allocations is n equal to 6 is equal to m plus n minus 1. So this is a non-degenerate initial basic feasible solution. So these are the non-degenerate basic feasible solution. Now if we check, they are not forming a loop. Their positions are the independent positions. Since they are in independent positions, so this is our the initial basic feasible solution by using the northwest corner rule. Now we are checking what is the transportation cost with our the initial basic feasible solution. Our initial basic feasible solution x11 is equal to 5, x21 is equal to 2, x22 is equal to 6, x32 is equal to 3, x33 is equal to 4, x43 is equal to 14, and the remaining all xij is equal to 0. And what is the cost? That we have to check. This is our the transportation cost, 2 into 5, 3 into 2, 3 into 6, 4 into 3, 7 into 4, 2 into 14. 2 into 5, 3 into 2, 3 into 6, 3 into 4, 4 into 7, 2 into 14. Last allocations is there. So this is equal to 102 unit. So this is our the transportation cost. Since there is no unit is given, that's why we are written is there the unit. We can write also the money unit if the money unit is given. That's why we are only written the unit is here.